Lecture 6 is related to realization of IIR filter, that is using the different delay, multiplier and adder circuits and different realization structures we have to study in this particular unit. So realization of IIR filter: direct form, transpose direct form, lattice ladder form, parallel realization, cascade realization, backward coupled realization, state space realization and implementation. Basic IR digital filter structures are: the causal IR digital filters we are concerned with in this course are characterized by a real rational transfer function of z raised to -1 or equivalently by a constant coefficient difference equation. From the difference equation representation, it can be seen that realization of causal IR digital filter requires some form of feedback. So an nth order IR digital transfer function is characterized by 2n plus 1 unique coefficient and in general requires 2n plus 1 multipliers and 2n 2 input adders or for implementation. Direct form IR filter structures in which the multiplier coefficients are precisely the coefficients of the transfer function. See the direct form, how we can implement it. Consider for simplicity a third order IR filter which has a transfer function h of z is equal to p of z by d of z is equal to p0 plus p1 z raised to -1 plus p2 z raised to -2 plus p3 z raised to -3 divided by 1 plus d1 z raised to -1 plus d2 z raised to -2 plus d3 z raised to -3. We can implement h of z as a cascade of two filter section as shown on the next slide. See this: x of z is given to h1 of z, the output of h1 of z is w of z, then it is given to h2 of z and the final output is y of z, where h1 of z is w of z by x of z which is equal to p of z and h2 of z is equal to y of z by w of z is equal to 1 upon d by z. And so total h of z is h1 of z into h2 of z which is y of z by x of z. So the filter sections h1 of z can be seen to be an FIR filter and can be realized as shown below. So h1 of z will going to be equal to, see, by taking the inverse z transform, the wn will be izt of w of z. So we will cross multiply it, the p0 terms we will multiply it by x of z. By taking izt it will be x of n, and so the w of n will be p0 into x of n plus p1 into x of n minus 1 plus p2 into x of n minus 2 plus p3 into x of n minus 3. So x of n minus 1 will going to be produced by the delay circuit, that is the z raised to -1, and the multiplier shown as in the triangle 1, and adder is a circle inside the summation is there. So x of n they multiplied by p0, so you will get one term p0 into x of n, then x of n minus 1 you will get by substituting z raised to -1, then multiplied by p1, then add it, then x of n minus 2, again another delay circuit you have to use, multiply it by p2, then add it, and for x of n minus 3 again another delay is used, multiply it by p3 and add all the terms, and final output w of n you will get. Similarly, the time domain representation of h2 of z is given by y of n is equal to w of n minus d1 y of n minus 1 minus d2 y of n minus 2 minus d3 y of n minus 3. And in the same manner we will going to realize this by using the delays, adder and the multiplier circuits. See the diagram which will going to give you the idea related with that. So y of n is equal to, see the w of n, then y of n is delayed by, so by taking that equal to z raised to -n minus 1, so y of n minus 1 multiplied by minus d1, then y of n minus 2, then y of n minus 3, and so second h2 of z term will be there. Now in third diagram we will going to cascade it. See, we have to cascade to two structures. The output of h1 of z is given to the input to the h2 of z. This is called as direct form 1 structure. So see, that is a direct form 1 structure shown in this particular PPT. In case of direct form 1 structure, we non-canonical as it employs 6 delays to realize third order transfer function. A transpose of the direct form structure is shown on the right and is called a direct form IT structure. That is a transpose structure. So what we had done, mirror image of that we had taken, and it is called as transpose of that structure. So various other non-canonical direct form structures can be derived by simple block diagram manipulation as shown below. So both delays we can combine together, that is called as direct form 2 structure. So combine 1 dash delay, 2 dash delay, 3 dash delay. So less delays we will require. See the diagram. Observe in the direct form structure shown below, the signal variable at nodes 1 and 1 dash are the same, and hence the 2 top delays can be shared. And so what we will going to do, the 2 top delays we will going to share. And similarly for 2 dash, similarly for 3 dash. And see, combining these 2 delays we will call, it is nothing but a direct form 2 structure. So instead of 6 we required only 3 structures. That is the main thing here. Direct form realization of nth order IIR transfer function should be evident. Similarly, in cascade form, h of z is equal to p of z. By different cascade forms we can do it. The direct form 1, direct form 2, or direct form 2, output of 1 is connected to output of 2, and so on. So this is the direct form structures shown in all figures. So it is a cascade form shown in all figure, parallel form, these all are parallel form. Then comparison of the complexity is given.